Can everybody hear me? Can you put the response in the chat? Can you guys hear me? Hello.
Yes, sir.
Okay, thank you. Not clear. Wait. How about now? Is still not clear? Okay, I'm getting some questions. Okay, we will answer these things in a few minutes. Okay, so can you all hear me? Okay, how about now? Is it clear now? I'm using a different headset.
Yes, sir.
Okay, okay, okay. Thank you. Okay, we I have a question. Okay, so very good question. I will answer this. Okay, so everyone can set the chat to directly to me, so you can answer me freely. Others will not judge you by your answers. And I am also encouraging everyone to answer to my question, so we can continue this lecture as a very interactive lecture. Okay, so one person is asking. So last time we I forgot to tell you Happy New Year, guys. So we are meeting for the first time in this year, right? So okay, Happy New Year to everyone. Okay, so uh, we talked about step potential in the last lecture. Um, so uh, a person is asking, if there's no gap between your 2 feet, uh, we will not get the electric shock. Yes, you will not get the electric shock through the earth. So there may be some flashbacks from the uh, whatever the arcing or the thing to you, but through the feet you will not get the electric shock. So if you have a very small gap between your feet, the potential difference between your feet will be very small. You will not feel that. Okay, so I think I clarified your answer, your question. Mm, so everyone can hear me, right? So can somebody again tell me? Can you share that video? Okay. Okay. I will share the link to that. Okay. Okay. Today we are going to learn about earthing systems. Have you seen earthing systems? Do you have earthing system at your home? Let's answer everybody. Do you have a earthing system at your home? Yes or no? Just simple answer. Do you have? Yes. Okay. Yeah. Okay. Okay, so I think you have some understanding about earthing systems, copper rods under the ground. Yeah, yeah, very good answers. Yes, okay. I think he is having an earthing system at your home. So today we are going to see the purpose of earthing and what are the earthing system types. So this lecture we are going to cover all those things, and I need to say this lecture is a bit advanced lecture because for you guys, because you guys haven't uh, like got the industry exposure, because in industry when you are going to a industrial workplace, they are always talking about these earthing installations, and that exposure is not with you guys, but I will explain these things simply as possible, and we have a separate lecture called earth resistivity studies. So even if you don't understand the stuff in here, you will clarify everything while doing that lecture. And if you have to do any clarifications while I'm talking, just put in the chat, I will answer. Okay, okay. So I'm going to start. Hmm. Okay. Earthing and grounding. So I have given the definition for you guys. So can someone say, if you know the answer for this, what is the difference between earthing and grounding? Do any of you know the difference between earthing and grounding? I know you have heard the substation grounding, and in your electronic devices, you connect the wires to ground. Okay, so can somebody say what is the difference between earthing and grounding? Yeah, I think okay. So okay, nobody is answering. Okay, anyway, so actually these two terms are identical. The difference is the region. So usually European countries and Asian countries, they use the term earthing, and American countries, they use the term grounding. So there's no difference between earthing and grounding. uh, Only difference is terminology depending on the region where you are going to use. And the when you refer to IEEE standards, so you know IEEE standards are based on USA. So those standards usually uh, use the term grounding for earthing systems, and BS standards, and BS means the standard we are going to use in this lecture series, BS 7671 and all those things use the earthing as the term for earthing or grounding. So you know what is the difference between earthing and grounding? There's no difference. Okay. Give me a second. Okay. So earthing is connection of non-current carrying part of electrical equipment to earth to maintain the earth potential. So you know, in our installations, let's say you have a oven connected to a socket outlet in your home. The enclosure of the oven is metal, right? So that part is non-current carrying part. So we should connect those parts to earth. So that is what is meant by earthing. So it is very important task. The earthing is required in all the installations we are having in domestic and all the other places. Earthing is very required. And when you have earthing, it keeps people safe by preventing electric shocks. So this is, I will show you a picture, so you will understand this very much after that. And it also prevent damage to electrical appliances and devices by preventing excessive current from running through the systems. We are going to understand this point later in this lecture slide. So main thing you should know is the earthing will keep people safe from electric shocks. So now I am going to share a um, small image. I need to check your knowledge on electrical systems, because I have to adapt the lecture depending on your knowledge. So you will need to answer my question to get that idea. Okay, give me a second. Can all of you can see this image? I shared a new window. Can all of you can see this? Somebody put the answer to the chat. Yes or no?
Yes, sir.
Yes. Okay. So we have one guy saying no. Are you still not seeing this image? A person touching installation? Okay. Now you can see, right? Okay. So we have, this is the usual supply. Let's assume this is the usual supply of your home. So you have single phase 230 supply, and that supply is connected to a, let's say this, let's assume this has a load, and there's a load, the wiring inside the load. So that single phase supply is connected to the load. And there's a conductive enclosure. Let's say this, let's take this as oven. So in the oven there's a heating coil and all those things, and the enclosure is metal. So if somebody is touching this, so please notice this side is not connected to ground, and this side is also not connected to ground. So if somebody is touching this conductive enclosure, will that person get a shock? Will this person get a shock? Can you guys answer from your basic electrical knowledge? Because this will require when you are going through this lecture. Yes. So this is conductive enclosure, but this is, yeah, no. So the answer should be no. So this is a enclosure. So there's a conductive elements inside, but these elements are not touching the enclosure. Circuit will ground to human. Okay. 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 I was expecting this answer. Okay. So first you should, so you know, to current to flow, there should be a path, right? So in here we have a isolated source. The source is isolated from the ground, and that source is supplying a load, and one person is touching the enclosure. So in here this enclosure is not energized, and this person will not get a shock due to the reason this enclosure is not energized. Now I am going to introduce a fault to this appliance. So now this wiring is wiring, let's assume one of the wires from this installation is detached from the circuit, and it is a live wire, and it is touching this enclosure. Now what is the answer? So now this enclosure is energized, so will this person get a shock? Yes. Okay. So from electrical circuits you should memorize this. There should be a path to flow, right? To current there should be a path, there should be a loop. So is there a loop in this system? So this source is isolated. Even though you have a potential here, will that potential cause a current flow this person's body? Because the circuit is not complete, see. So there should be a complete circuit to to current to flow. So this is 230 volt supply. To this person to get a shock, there should be a connection from the neutral or ground of this supply to earth. Now this circuit is complete. So if that person is if this appliance is faulty, your current will pass through this line, and it will touch the enclosure through the fault, and now this is the path. Then it will pass through the conductive enclosure and pass through this person's body and pass through legs and from the conductive surface. So you have to make sure this make sure you know this. I have indicated this surface is conductive. To the conductive surface this circuit will complete, right? So now there's a current flow through through this person's body, therefore this person will get a shock. So if this supply is isolated, this person will not get a shock. So you should know this, because there's a earthing system where the supply is isolated. So you will learn that system in this lecture. The person will not get a shock even if there's a fault inside your in your appliance. So it is a very special system, not recommended to use in domestic environments. We will see what is the reason. Okay, now let's say I am into. So okay, do you guys know what is the usual impedance of a human body? You Impedance means resistance. Okay, what is the usual human body resistance? Do you guys know the answer? Okay, actually, uh, this human body is modeled using several capacitors and inductors and all. Because of that, the frequency will vary the human resistance. So usually for DC, the human resistance is very high. If you have AC with 50 hertz and 230 volts range, your human body resistance is usually we take that as 1500 ohms. So usually we say our human body resistance is 1500 ohms. So that is a norm, so you guys can memorize that. And so now if this person is touching this circuit, it is like we have connected the 1500 ohm resistance from this point to the conductive surface. Let's take this as a wire. Let's take this surface does not have a very small resistance. Okay, now I am going to connect a wire from this point to this point. Okay. Now, even if there's a fault in here, so you know now the circuit has completed through the fault. Now we have a current flow and we have parallel resistances. So now this resistance is 1500 and this resistance is almost close to zero. So through which resistor the high current will flow? So let's say this one as R and this one as RH. Okay, so through, yeah, high current will flow through R, right? So and the current through human body will be very low, because there's a conductive higher lower impedance path through this wire. So this is simply what we are doing by earthing. So now I think everybody has understood, right? So did you understood what is the purpose of earthing? Please tell me yes or no. So now we are introducing a low impedance path from the enclosure to the ground, uh, to save this human being. So I only got 1 years. So have all of you have understood the purpose of earthing? Yes. Okay. Yes. Okay. Now I think you are in a position to continue this lecture. So today also we are having little bit of theory parts, and this will be a little bit boring lecture, because after eating you guys are also sleepy. I'm also sleepy. So don't worry. We will go through the lecture as interactively as much as possible. Okay. Now I'm going to move on to the lecture. So okay. So, do you remember last time we talked about two main components of elect distribution systems? Do you remember what are the components of a distribution system? Major components. I will say one. Okay, we will have the source. What is the other one? Installation. Yes. Yeah. So we have power source and the installation, and we can take this diagram to usually indicate a installation in our domestic environment. And I think you guys also remember the uh, two letter code. I also mentioned, I think I mentioned this is a standard letter code. We usually indicate source by X, installation by Y. So just something additional to knowledge. And installation in here, when you are grounding, we are so earlier we also discussed, we are grounding exposed conductive parts. Usually exposed conductive parts are enclosures. So we will see in detail what are the exposed conductive parts. So you should know the two letter code. Actually this is not very much useful, but we have this notation. So now we are coming to the exposed conductive parts. I think you also understood this by listening to the earlier part of this lecture. So usually exposed conductive parts are they can be readily be touched. So enclose of oven, metallic enclose of oven. So you should not get a shock by touching your oven. And you can have computer. So usually nowadays computer casings, they come use metal, glass and everything. Let's take a old computer case and usually metal, and those things can also take as exposed conductive parts. And can few of you say what are the other exposed conductive parts you can think of? Okay. It's a very easy question. So everything metallic surrounding your appliances will be an exposed conductive part. I hope everyone got the understanding. Okay. I'm moving on to the next slide. Okay. Now we talked about the two major components of distribution system. So we have power source and we have the installation. So earthing is done on both sides. So first we are going to talk about source or X earthing. For the source side, there can be two configurations. So now I am talking about only the source side. So earlier we talked about the installation side, but we are going to talk about that in detail in the next slide. So usually there are standard configurations for earthing. For a source, these are the two configurations of earthing. The first one is the source neutral is directly connected to earth. So this is called terra. Terra is a, I think, Latin or some term to earth. Terra means earth or earth. And the second configuration is neutral point of source is not earth. That means isolated or connected to earth through a very high impedance. Impedance is a resistance. So I think you guys know what is an impedance. Usually, let's say impedance is an resistance. So if you guys have any clarifications to do, please put in the chat. I know some words are new, maybe new to you guys. Please tell me so I can explain that term or something in more detail. So you should know now source thing can be done in two ways. The first one is connecting the source neutral to earth, and connecting the not connecting the source neutral to earth, or connecting to earth through a high impedance. So this is directly connecting the source neutral to earth, and in this diagram the source is isolated. That means it is not connected to earth. So these are the two standard configurations of earthing defined for source side. Now installation or exposed conductive parts earthing, this is the one we earlier talked about. And in here also we can have two configurations. The first one is uh, the conductive parts are separately earth. Separately earth means this is also terra, similar to terra in the source earthing. We are directly connecting exposed conductive parts to earth. And the second one is, so earlier remember we did not connect anything to in the isolated one, in our neutral is not connected to ground. So in in the exposed conductive part earthing, we are connecting everything to neutral. So that is called N. So we are using the term N for that. So in exposed conductive part earthing, we have two configurations. One is we are connecting the exposed conductive parts to earth. In the second one, we are connecting the exposed conductive parts to the incoming neutral wire. In here, you do not need to do that through a wire. Usually what we do is, so we are anyway taking a neutral to the circuit. We are connecting this enclosure to that neutral point in the circuit from an inside wire in the system. So that is what you should know. Okay. Now we have understood what are the two configurations available of source earthing and the exposed conductive part earthing. So bear with me. These things actually you will not get any questions from this, because these things are usually the things you should know. But I am not going to give you any questions from this part, because we have a lot of calculations to do from these things, and just know these things. If you don't understand, please ask me questions. I will clarify. I hope everybody is following me, and please put in the chat if you have any questions. Okay, sorry. Okay, so if you have two possibilities for a source side and two possibilities for the installation side, how many earthing systems we can have, how many combinations you can have if you have two so this is something like binary, like, so in here you have zeroth location. In the first location you can have two possibilities. How many yeah, four. So I got the answer. You can have four combinations from these thing configurations. The first one is you can have source connected to earth and installation connected to earth. So this is called TT. And the second one is you can have source connected directly to earth and installation not earth. You are connecting installation enclosures to neutral. And the third one is you are keeping source isolated and installation connected to earth. And there's a we can have a four combination. One is IN. So the next one is IN, but this is actually not a earthing system. So to be an earthing system, you should connect at least one side to the earth. Earth means the soil. So in the first system, both sides are connected to earth. In the second system, source side is connected to earth, installation side is not. In the third system, source side is not connected to earth, but installation is connected to earth. But in the fourth, IN type, source is not connected, installation is also not connected. So this is not an earthing system. So we are not allowing IN system. So we have three earthing system combinations available in earthing system installations. So we have several sub variants also. So the major one is TT, then we have TN, then IT. IN is prohibited because there's no paths to earth, because it is not connected to earth. Okay, so now I think you have a understanding about these installations. And so think about is your house is having a ground connection, is your transformer is having a ground connection, or your house all the earth enclosures are connected to neutral coming from the distribution side. So think about those things and tell me what is the earthing system we have in Sri Lanka. So you can now evaluate your house system, in the system in your available in your house. So consider, is your house installations are connected to earth. So I think you have seen the transformer next to your home, and is it connected to earth? What is the system we are having in Sri Lanka? So I have one answer actually, TN. So I think everybody is having an earth rod in your houses, right? So if you have an earth rod driven to the soil, it is T. Yeah, we are having TT in our homes as the earthing system. So that is the earthing system we are using in Sri Lanka. Okay. Okay. Actually, this that question has a small error. This is not the only earthing system used in Sri Lanka. It is only for the domestic customers. Domestic customers should have this TT system. We will see why. Okay. Now, earlier I said that TT is only for domestic customers. Domestic customers are also called LV customers. So LV customers should have this TT installer, TT earthing system installed in their house. So domestic customers can be categorized as the customers with a demand lower than 42 kVA. So usually you have seen houses with single phase 15 ampere connections, single phase 30 ampere connections. If you, I think if you know about your uh, meter panel in your home, there will be a breaker or a cutoff. That cutoff is rated for some value. Usually 30 ampere connections will have a cutoff of 40 ampere. So go and check those things out and define what is the customer category you are in. So usually three phase we have 30 ampere, three phase 60 ampere. So these are the LV customers. LV customers can only have TT earthing system. So these are just for your knowledge, and you should know this because when you are going to wire your house, you should design your earthing system according to TT rules. And if you are a LV bulk customer. LV bulk customer means your demand is higher than 42 kVA. And if you are a CB customer, the range is 42 kVA to 1000 kVA. If you are a LECO customer, the range is 42 to 1500 kVA. So for LV bulk customers, if you are requesting a supply from your power supplier, electricity supplier, they will provide you with a free transformer. So that means you have a dedicated transformer to your premise. So in that case you can have TT or TN. So if you are getting your power supply from a common transformer, that means one transformer is feeding lot of houses, you can't have TN, you only can have TT. But if you are having a dedicated transformer to your place, you can either have TT or TN. Usually in SLIT, our new engineering faculty is wired in TN system. We are going to talk about uh, the subcategory. There's several TN systems. We are going to learn about them in few slides. And if your demand is higher than 1000 kVA for CEB or 1500 kVA for LECO, you are considered as a HV bulk. So HV bulk, usually the metering is done in 11 kV or 33 kV supply, because transformer is provided by the customer. So you have to buy a transformer if your demand is higher than this value. So the CEB will connect the meter in the high voltage side of the transformer. So those customers can also have TT or TN. So this is actually bit important for you guys, because when you are going to design a earthing system for an installation, so when you are going to work in the industry, people one there will be a request from a customer to design an earthing system or wiring system. Usually you design the whole wiring, and you should consider the facts and decide what is the earthing system we can use in the uh, in that premise. And now we are coming to the IT system. IT system is the one I told you about earlier. IT system, the source side is isolated. So because of that isolation, there's no circuit connection from the circuit will not complete even if there's a fall through your exposed conductive path. So those things are used in special locations such as surgical theaters, hospitals, where you need the continuity of supply. So even there's a earth fault in your system, you should be able to do the operation. So in surgical theaters we have IT systems. Usually in IT systems they have separate transformer, and after that separate transformer they will have the surgical theater. That's how IT systems are wired. Okay, now we are going to talk about TT system. This is the most common system in Sri Lanka. In your house, there's a TT system, and go if you can find your rod in your house, and please like check the wire gauge of the wire connected to your earth rod. Check those things and check your fuse panel. I will check. I will tell you few stuff. You can check those things in your fuse panel and get the understanding about your earthing system in your home. Okay. So as mentioned before, in TT system, source is directly earth, and exposed conductive parts at the installation are also earth. So in here, see, through one or more earth electrodes. So that means we are trying to reduce uh, our earth electrode resistance, because when you have more electrodes we have more parallel paths for the current to flow. So you are reducing the earth electrode, so that means the harm done to your human body will be lower when you have a high earth electrode low earth electrode resistance. Now 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 we are going to define the earth loop impedance of TT system. So this is one of the most important things you should know. So when you have a TT system, uh, you are um, assume you have a fault in your system, and that when that fault occurs, there's a path to current. Earlier we also discussed that there's a path to that current to flow. So that the impedance or resistance of that path is called the earth loop impedance. Usually we call that a impedance because there are capacitive elements also in that path. Therefore we can't take that as completely resistive. So we are going to define how what is the earth loop impedance path of TT system. So you are given a installation wiring diagram, and you can see we have a we have a fault. We have a fault in the system. So let's say this the fault means one line has detached from the circuit and it is touching the enclosure of this installation. So you can estimate what is the flow of current, the path of flowing current. So I am going to draw the path of flowing current in this diagram. Okay. Now let's assume our that detached wire is connected to line one, the phase one. So this is a three-phase supply, but that wire is connected from the L1 path. Let's take L1 as the supplying connection to that fault. So your fault current will flow through this path, and from the inside it will go here and it will touch your enclosure, and from the enclosure it will go through the earth rod to earth and comes back to the earth rod of your source side. So this is the earth loop. So see, this is a loop. So this is neutral, and neutral means, so in a three-phase supply, so let's assume this is a star. So now this point is N, this point is Earth. So that is what is the connection I have indicated here. So this is the path you have for your fault current. So this path, the resistance of this path is called earth loop impedance. So if you observe the TT system, you can see the the path that current flowing is not completely metallic. So you have earth here, and after that you have the path through soil, your earth. So that path is not metallic, but starting from here, this is a copper or aluminum conductor, this is a conductor, and enclosure is also conductive. So this path is metallic and this path is not metallic. Due to that, in a TT system, our earth fault currents are bit lower. So usually in an installation, our earth loop impedance, this impedance we are taking as usually 10 ohms. So we are going to see these things in the lab we are going to have in this lecture series. Usually earth loop impedance will be 10 ohms. And if you have any questions, please ask. Wait, chat window is not there. Okay. Still, I am not getting any questions. So if you are following, if you, please, like these are just for your understanding, but these things are important. I'm not going to test on these things in exam. I will give some questions from the impedances and all, but these are basic knowledge, so you should have this. Uh, so I am a little bit worried because you guys did not go to the industrial training. I'm worried because maybe you are not understanding this. If you are not understanding this, please put that in the chat box so I can explain that further. Okay. Uh, so I said someone is the float impedance. No, that is the impedance through earth. Earth loop impedance is the total loop impedance. So earth loop impedance, see, Z is the earth loop impedance. So Z1, Z2, Z3, the the addition of all those things will be earth loop impedance. Okay, so good question. So if you have any clarification to do, please ask this. There's no incorrect questions or answers. Please ask questions from me. Okay. Okay, so now you might be wondering how this soil is conducting electricity. So if you take a soil sample from your home, that will not conduct electricity, right? Uh, no, is 10 ohm? No, 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 no. 10 ohm is not a constant. We are designing our earth impedance as to be a 10 ohm system. So you will see these things in the industry. You will set a meter and measure the earth. This one is called earth electrode resistance. So this is earth loop impedance. So earth electrode resistance, we are keeping that at somewhere around 10 ohms. Usually this can be much higher depending on your soil and your earthing system. If you have only one rod, this will be very high. That can happen, but usually in the installation in a TT system, our recommended value is 10 ohms. So you will understand these things when you are first getting the exposure from your uh, industrial training. So it is not a constant. It will vary depending on lot of conditions. And you will now you might be wondering how that soil is conducting electricity. Now, if you take a soil sample from your house, it will not conduct electricity, right? So soil is not a conductive material, but it has some resistivity. So our resistance is defined as rho L over A, right? So in here, rho is resistivity, it's coefficient that is a uh, property of the soil in here. So it depends on the what type of soil you have, and L is the distance, and this is A. So if you have ground rod driven to earth, so let's say, and This is the ground rod, and this is earth. And think about the area this connection has. According to this, if current flow through the red line, is it possible to pass current for a long distance? Because transformer is no, this is fault condition. This is not the usual condition. Okay, so we are now coming towards fault condition. So earthing is done to prevent you from faults. So if there's a enclosure energized, we should identify that, and we should the keep that enclosures voltage in a safe level, that you will not get a shock. Usually we have, I am coming to that in few seconds. We are not going to keep our connection like this. If you have this condition, we are going to immediately trip the circuit. So I am coming to this now. So okay, you will understand this. Is it possible to pass current for a long distance because transformer is far away from the consumer? Okay, so okay, I think I am not understanding your question. Maybe are you confused with the resistivity in here? So I'm going to explain that. Okay, listen to this part. So you will, I think you will understand this. Okay, so you have earth rod driven to your soil, and so this is the total earth, right? You have lot of area. So this A is very high, so your resistance will get lower depending on the area, and this R rho coefficient is usually higher for soil, and with that and higher rho and higher A, you will have some impedance through earth, but it is not large as metallic connection. So this is what you should understand. So maybe you will think earth is a good the soil is a good conductor. It is not a good conductor. This is what actually happens. Your resistance go down because the 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 area that your connection have, that resistive component will have a greater area, so that will reduce your R. That is what happens here. So you will learn these things in the resistivity studies. I think it is the fourth lecture. So the question, did I answer your question? This is it possible to pass current for a long distance? I did not understand that question very precisely. If you can elaborate, I can explain further. Did I answer that, or do you need more explanation? If you got the answer, just say yes. I mean, is it possible to pass current through earth for a long distance? Actually, it will go for a long distance. Actually, if you are having trouble understanding this, understand that like this. Okay. So I am going for a much easier explanation. What let's think, this is what happens here. So you are injecting some of the electrons here, right, to the earth. You are injecting some of the electrons. So you know earth is a very large object, and that can hold very high number of electrons. So what happens is, so if you are injecting high number of electrons to earth due to this fault, and in here you are deprived of electrons, so you are having less number of electrons here. So what happens is, you are injecting electrons here, and earth will hold those electrons, and you need to neutralize the deprivation in here using some electrons. So what will happen is, earth will provide those electrons from here. So understand that it as like that. If you have a question, actually this is not a power current transfer method. This is actually that question also came in the last semester also. People are having trouble understanding this path through earth. So actually there will be a current flow that is just for your uh, you will understand this. Okay, don't worry about that. You will understand that in the sixth or fourth lecture. I don't remember the exact number. There will be a separate lecture for earth resistivity studies. Okay. And so because this electrode resistance, the earth resistance is higher, our fault currents are low. So earth loop impedance is high because there's a ground return. Ground return is the non-metallic path. So ground return is much more higher. Ground return has a much more higher resistance than this metallic path. So this ZE will be higher compared to the other earthing systems, which are okay, we will come to that later. So ZB will be somewhat higher, so our fault current will be lower. So we may need sensitive devices to detect these faults. So if you have a fault condition in your earthing system, we are not going to keep that forever, because it is harmful to your source, and it is harmful to the uh, human beings around that. So therefore, we are going to instantly trip the circuit if there's a earth fault. So to do that, we are going to use a device. So, so I think you guys know about RCDs, right? Did you? I think I asked you in the last lecture to check the RCD available in your house. Did you guys see the RCD in your house? What is it called in normal words? So in normal, language, we are calling it another name. We are not calling it is RCD. It has RCD, trip switch. Yeah, it is the name. So the trip switch is a very sensitive device. So it is to detect these earth faults. And you may now think trip switch also trips when there's lightning, right? We will learn about that also in this lecture. On not in this lecture, we will come to that in later lecture. Okay. So the main purpose of trip switch is detecting these uh, earth fault currents. So now we are going to see about RCDs. So RCDs, or trip switch in Sri Lankan language, and not in Sri Lankan language. Usually we use the trip switch term to indicate RCD. And this RCD term also, the RCDs are called GFCIs in American countries. So it is similar to that. This is ground fault circuit interrupter. So in American countries, they are not using the term earth. They are using ground. So they call GFCI uh, as they called RCD is called GFCI in American countries. So uh, RCDs are designed to detect leakage currents. Leakage currents means, so in a system, if you provide some amount of currents to the circuit, that amount should come out of neutral, right? So to it is the simple Kirchhoff current law. So if you are providing a current to a system, that current should come through the neutral, equal current. So if there's a leakage, that there will be a misbalance between these two currents. So RCD will find these misbalances and trip the circuit. So I think you can understand. Uh, so usual current flow of this circuit will be, if you take the same line, will be, it will come through L1 and go through neutral. Can you understand? It will go through. So this current will not, if there's no fault, this current will go through this path. I think you are also all are following me. It will go through this path to neutral. So that is what Kirchhoff current law says. So the current coming from this path should go to this point through this line. So what we are doing is we are connecting RCD. RCD has two terminals. So RCD, two terminals if single phase, If it is a three phase, it has 4 terminals. So what it does is we are measuring the current here. Let's say this is 1 ampere, and this also should be 1 ampere. Otherwise, it will trip. So that is the operation of RCD. So now I am only talking about single phase supply. If it is three phase, in three phase supply, RCDs work in a different way. So I think balance. You guys have you guys learned about balanced three phase supplies? Is that part covered in your curriculum? Is I think it is second year, right? Someone
Yes,
answer
sir.
is yes or no? Yes, yeah. So in balance three phase supply, neutral current will be zero. Actually, it will not be zero. We will come to that in next lecture. So there are a lot of uh, new things you are going to learn in this lecture series. It will be zero if only fundamental currents are flowing. If you have other harmonics and all, it will not be zero. So we are going to do an evaluation. We are going to do an evaluation on that also. Those are very easy things. Don't the main thing in this power engineering is the terminology is very difficult, but when you understand the thing, very easy. So I am going to teach all those things in a very easy manner. uh, don't worry about those terms. Everyone will understand those things. Okay. Okay. So now RCDs. So as I explained, these RCDs will detect misbalances in your current in the supply and the return. Return is the neutral, supply is the line. And it will trip if there's a misbalance. So usually, I think you know about circuit breakers, right? Circuit breakers or current protective device. So I think in your houses you have 5 ampere circuit breakers. What are the other things? 10 ampere circuit breakers. And if you tell me few other values you know about circuit breakers. Circuit breakers are MCBs. What are the values you know? Just say what are the values you have in your home. 5 ampere there, 10 ampere is there. I'm checking whether you guys are sleeping or not. Okay, what are the values you know? Just give me an answer. Don't I'm not going to tell your name, and if it is wrong, I'm not going to yeah, 16 ampere. Okay, one guy is answering. No, several guys. Yeah. Okay. 16 amperes there, again 20, 25, all those things are there. So you are going to learn those things in the next lecture, but those things are usually basic knowledge. But don't worry, you are going to gain that knowledge in several lectures. Okay. So in MCBs, uh, those things work in a different principle. MCBs will trip if their rated value is exceeded. So in here you guys said you have 16 ampere breaker. So 16 ampere breaker will never trip for 15 ampere or 16 amperes. It will be the tripping current of the breaker will be higher than 16 amperes. But when it comes to RCDs, these are little bit different. So usually there's a rating of the RCD rating. It is the must trip value. So it should trip before the rating. So let's say your RCD is rated for 100 milliamperes. So it should never go to 100 milliamp more than 100 milliamperes when tripping. It should trip before 100 milliamperes. Usually we say RCDs will trip between the half of the rating and its rating. So if 100 milliampere RCD will trip if the leakage current is higher than 50 milliampere or less than 100 milliampere. So that is the principle of rating of these RCDs. And so now there's a question. So I need an answer for this because I think you guys should know this. uh, what is the most common RCD rating used in Sri Lankan household? So if you know now there are 16 ampere MCBs in your house. So did you have ever checked the rating of your RCD? Do you know the rating of your RCD? Tell me, what is the most common RCD used in Sri Lanka? Just give me an answer. I'm not going to humiliate you or any other thing. So I understand this lecture is a bit boring, but don't worry. So in coming from the next lecture, so you will be doing calculations and also it will not be boring as today's lecture. Okay. So most common RCD used in Sri Lanka is 30 milliamperes. So there, so if you now go to your, not now, after this lecture, go to your fuse panel and check the rating of your RCD. Usually it should be an 30 milliampere RCD. So that is the rating recommended for households. Okay. So now I am going to cover several things about these RCDs, because these things you should know. I know a bit boring, but please go through this. I will go through this and listen to me, and after listen to video also, because you need to understand these things. And there are several types of, actually two types of RCDs, and under these types there are several classes of RCDs. So in RCDs, actually there's the general type and time delayed type. This is also one thing RCDs have different from the MCBs. So MCBs, they are always they are tripping according to some time curve. There's instantaneous protection. We are coming to that later. Usually, RCDs are instantaneous devices. So what happens is, if you have a leakage current, it trips your circuit once it detects instantaneously. So RCD should be an instantaneous device. So, but when it comes to larger buildings, so let's say you have several floors with 30 milliampere RCDs, but for the main distribution panel, you can't put another 30 milliampere RCD, because there will be uh, false strippings, or uh, if you only need to isolate one part of the building, if this one is 30 ampere or 100 milliampere, if it is a general type, every every RCD will trip instantaneously, uh, cutting all the power supply to your uh, building. So therefore we need to have delayed type RCDs. So main two types. First one is general types, which are instantaneously operating, and the second one is time delayed types. So 100 milliampere. In here it is a S type. So S means slow type. So this is general type, slow type. So slow type will take some time to trip. So these are only for the purpose of this is called discrimination, only for the purpose of discrimination. So in a case of fault, only lower level of installations will be tripped without interrupting the other levels. So that is the main purpose. So we are also having a lab on this, not in RCDs. We are going to do a lab on discrimination, so you guys will understand these discrimination studies in a few upcoming lectures. And that is the main thing you need to know about RCDs. Okay. Mm, read these things, you will understand. Okay. And I have included several RCD types. So this is called type AC. So this is G type. This is the usual one you are having in your house. So only detect pure 50 hertz pure sine wave residual current. So this is go and check your household fuse board and check the RCD class. After this lecture, I have uploaded the lecture to the. I will upload the updated version. I think there were several changes in here. But because of the request, I uploaded the last year's one. And so go and check your RCD type in your house. And this is type AC. It can only detect pure 50 hertz pure sine wave. And this is called type A. It can detect additional to sinusoidal 50 hertz, it can detect pulsate in DC. So this will be the logo. So maybe you can have these kind of RCDs in your home. So go and check. So I'm going to go through this bit faster, because today's lecture is, I am feeling you guys are a bit bored. Okay. Um, okay, type F, high free. This one can detect everything that type A can detect. That means 50 hertz sinusoidal and pulsating DC, and also additionally high frequency residual currents. So high frequency residual currents, this is bit important because when you have solar and all, there are high frequency residual currents in your houses if you have solar. So usually if you are actually this is not very important to solar installations in Sri Lanka because those things are grid tie units. So if you have a hybrid units, you should have one of these kind of RCD. And the type B can also detect misbalances in smooth DC residual currents. Okay. Okay. So I think all of you have understood the uh, RCD classes and the purposes of RCD. So can someone give me feedback? Did you understand what RCD does? Yes. Okay. Thank you. Okay. I'm appreciating these answers because I'm also feeling bored, after eating and all. So I know you guys are bored also. Okay. And I think so. Since I am not getting many interactions from you guys, I think we should have a like 2-3 minute break. What is the time now? It is 39. 2:39. Okay. So I am going to give you a 2 minute break. So go and drink some water and come. Okay. So I will start at 42. Okay. So the best. Okay, I will answer these questions. Is the best RCD type B? Yes, because it can detect lot of types of uh, residual currents. Residual currents is actually misbalances. So this is also called differential protection. Yeah, type B is the best class, but we are not going to use the best class in normal household installations. We are going to stick to type AC. So so when you are drinking water, you can also check the fuse type you have in your home. What is the type? So I'm going to give you a 2 minute break. So it is 40. I'm coming back at 42. I'm also going to drink some water. Okay. So come back at 2:42. So you can post your questions here. So you have 2 minutes. If you are not going out, you can post your questions. I will answer them after coming back. Okay. Okay. So I I'm back again. So I think all of you are also here. So I will talk about few other stuff if somebody is not here. Okay. So I've been meaning to tell you guys about your uh, subject selection. I got lot of emails, and so the thing is, so you know that even if our degree is electrical and electronic, and it has they have mentioned a lot of specializations in your degree certificate, they are not going to mention the specialization what the you have done. So then what happens is, when you are going to the IESL, they are going to consider you as electrical and electronic engineering graduate. Okay, so are you everybody here? So can someone put yes in here? Someone, not someone, put everybody yes here if you are here, if you are listening to me. Okay, okay, okay. So IESL is going to consider you guys as electrical and electronic graduates. So what they are going to do is, they are going to give you a general paper. So I also I got this I thought of telling you this because so if you go to IESL website, so I will show you the curriculum. So you need to cover these areas as an electrical and electronic engineer. So wait, I will show you the things they require. Can you guys see this screen, the my browser? Okay, yes. Okay. So this is the examination you are going to write at the end of your graduation, not the graduation. So you will graduate at I think 2022, 2022, right? This is, no, 2023, I think. Okay. So you will graduate in the month of February, and this ISL exam will be there after a year. So probably in the next year's February. So they will give you all the syllabus and assessment details. So in electrical engineering people, they are going to write uh, this paper, the paper A. So I will also show you the model paper. So it is completely MCQ based, 120 MCQs. You will have to get 60 out of it, no negative marks. That is how engineering graduates are going to get assessed, slit graduates. So usually slit graduates will have to write to this examination. So you should select your subjects to cover the syllabus needed to write this paper. So I think so. As a sleep graduate, I should guide you on this, because we are the ones firstly experience this. So this is the syllabus. This is the paper A syllabus. This is the syllabus they are going to check your knowledge on. So circuit analysis. These things are covered for you guys. So you do not need to worry. And field and measurements. So field and measurements is actually engineering electromagnetic. So this is common for all the so you guys may be doing electrical, electronic and computer systems. What you do is doesn't matter, they are going to ask you questions from this. So you should at least take few subjects. So this is here, circuit analysis, 10 MCQs will come from this. And fields and measurements, 12 questions, field and measurements, usually electrical machines, uh, what are the other things, the electrical, electromagnetics, electromagnetic energy conversion, I think those are core subjects. So those things, from those subjects there will be 12 MCQs. And next things are machines is also here, machines and drives means power electronics. So machines and drives, there will be 12 questions. And power systems, so even if you are doing computer systems, you will have to face this examination. Power systems 12, machines 12. So I am recommending you to do this subject if you are planning to stay in Sri Lanka. And control systems, this is compulsory, you know, do not need to worry. And electrical installation, so even if it is not a core subject uh, in SLIT curriculum, they are taking electrical installation as a core subject, because in core subjects they are offering you 12 MCQs. And high voltage engineering, five questions, not a core subject. And power electronics and applications, also a core subject. And here we have our curriculum has power electronics and power electronics and drives and machines. So those things, 36 MCQs out of 120 MCQs. So you have to I think you will have to at least do one of the power electronic subjects. And energy systems, I think now they are introducing utility engineering, I think in fourth year, so no need to worry. And power engineering, this is not covered in our module, so we will have to learn these things from some other sources, but only 3 MCQs out of 120, so no need to worry. And as electrical people subjects, microelectronics, so microelectronics cover everything, I think. See, uh, yes, doing ISL exam is required for select graduates. Yes, for now it is required. Not compulsory, but you can work. But you know, without associate membership of ISL, you can't put that engineering. You can't specify yourself as engineer without ISL. So actually, this exam is not very hard. So if you check the uh, model paper, not a very hard examination, but you need to score 60 out of 120 to score 60. You need to collect all these like basic knowledge. So I am also recommending to look this uh, syllabus at isl.lk. And how much pay for that exam? They are their pay is bit high, I think. uh, for us it was 27,500. They are increasing that each year. Now I think it is 35,000. um, okay, so if you need more information, you guys can email me or whatever. So if you need any guidance on that. Okay, so now I'm going to again go to the lecture. Mm, okay, so now we discussed about RCDs. uh, okay, so I said this RCDs has ratings, right? So in Sri Lanka, most common one is 30 milliampere. To to uh, so we need to do our earthing arrangement design, earth loop impedance design, according to this RCD rating. So I think we discussed safe touch voltage is 50 volts for AC, constant for each application. So you should remember this value, very important. Safe touch voltage is 50 volts AC. So I'm sorry. And our RCD ratings for household is 30 milliamperes. So we need to calculate the resistance, earth loop impedance required to trip this RCD at 30 milliamperes. So very easy calculation. So you can use this equation. So this is simply V equals IR. So we can take I as 30 milliamperes, V as safe touch voltage, and earth loop impedance. Safe touch voltage. Why you may wondering why we are getting safe touch voltage here? Because if it trips for safe touch voltage, if you so wait, I will explain in. Okay, in here this fault can also have a impedance. So you know that live wire will be at 230 volts, but there will be a impedance in this fault. So through this fault there will be a voltage drop, and this enclosure might be at a different voltage because of the drop here. So therefore we can't define this this enclosure, we can't say this enclosure is at our rated voltage. That's why we are taking our safe touch voltage, because we need to protect the safe in the safe touch voltage, people will not get a dangerous shock. That's why we are defining safe touch voltage here, and after doing the calculation you will get 1666 ohms, so very high value. But this is only a theoretical value. So more than 200 ohms is unstable, because this soil resistivity will change depending on the season of the year. So in January it will be low, in August it will be high, depending on the wet conditions, high conditions. So usually we say more than 200 ohms is unstable, so we cannot define this as the highest value. So this is just for your knowledge. So if I gave you a question saying 100 milliampere RCD, what is the earth loop impedance, you can use this equation to maximum earth loop to calculate maximum earth loop impedance. And BS7671 table 41.5 specifies these values, and for 30 the value we got just now, and 100 milliampere RCD 500 ohms, 300 167, 500 milliampere 100 ohms. So if you multiply these all these values you will get 50 volts. So that is the safe touch voltage. And they have also specified the exceeding 200 ohms may not be stable. Okay, so keep these things in your mind. So I know the today's lecture is more theory, but don't worry, in up from next lecture you will have to do calculations. Now we learned we now I think we covered everything in TT system. Now we are moving on to the TN system. So in TN system, so I said source is directly connected to earth, and installation is connected to neutral. This connection to neutral can be done in several ways. So depending on that way, we are categorizing these systems into few other subcategories. So first we are going to talk about TNC. TNC means TN combined. Combined means, so you only have four wires coming. So similar to Sri Lankan system, only four wires in the distribution line, and the distribution line neutral is connected to all the enclosures, metallic enclosures in your home. So this is actually not a very good system. I will explain why. So combined means you do not have a separate wire to connect this earth. So in TT system we are getting a wire from here and connecting it directly to ground. So you are not utilizing neutral as uh, your return conductor as a earthing conductor. uh, but in here we are using our neutral conductor as a earthing conductor in TNC system. That is why it is called combined. So when it is a combined system, it is called PEN, protective, earth and neutral. So that is how a TN system is wired. And this is the earth loop impedance path of TNC system. And similar to let's say our fault is in L1, similar to the TT system we considered earlier, and your fault current is coming, and from the inside it is shorting to the enclosure, and through the enclosure it is going to be neutral again. So actually you may remember earlier I said this wire actually you do not need, you can just put a wire here and connect it to here without an issue, because the same potential. And mostly from the inside this wire is connected to a neutral point at your circuit. So that is how a TN appliance for a TN system is used. Okay, so main drawback of TN system is we can't implement RCDs in TN systems. So you may remember earlier when we are give me a second. When we are considering about the TT system, we connected RCD to this point. If you're considering a single phase connection, and current through, if here it is 1 amp, if here it is 1 amp, we can detect a fault. But the drawback of TN system is even if you connect a RCD here, your fault current also passes through this neutral conductor. See, so earlier the fault current went through our earth loop, but now the fault current also go through the neutral. So you can't use RCDs in TNC system. So it is one of the disadvantage of TNC system, and this is the least safe system in the earthing system category. And the other thing is, in TN system, earth loop impedance is low. See, all the paths are metallic. So your current is coming here and going through the enclosure and again going to the neutral and flow through the neutral. It is going to the earth of the source, neutral of the source, and therefore all the earth loop is made out of uh, metallic path, metallic wires. So loop impedance is low, your fault currents will be very high uh, in the TNC system. Therefore the overcurrent protection devices can be used to resolve earth faults. So we say overcurrent protection devices can be used to resolve earth fault, but it is not very effective. So we will see why. And the because of the not capability of it is not, if it is not capable of taking RCDs, we can't consider it as a safe system. So TNC is the least safe system in earthing systems. So just know these things and read the lecture slides so you will understand. Okay, TNC system is only used for low power application because it is less safe, and sensitive protection devices like RCDs are not supported by TNC systems. So I think you understood that. And overcurrent protection is not very sensitive. So that's what I mentioned. So usually, uh, as I mentioned earlier, 10 ampere breaker will not trip for 11 amperes in in a in instantaneously. So it will takes few hours to operate because we in a if you consider a time curve, we will learn about them in upcoming lectures. So if you have a 10 amp breaker, it will start to trip at 1.45 times the uh, rated current. So if it is 10 amps, usually it will trip at 14.5 amps at a finite time limit. So it will trip at 11 amps, but the thing is it will take a few hours. So we are taking that as infinite time. So using overcurrent protection as a tripping circuit for earth faults is not very good. So that is one of the major disadvantage of TNC system. And so we can also do calculations to design overcurrent protection for TNC systems. And so let's say our so in TNC systems our loop impedance are low. So I earlier said our in TT systems loop impedance is around 10 ohms. In TN systems it is 1.5, probably less than that. So we can so if earth loop impedance is 1.5, we can calculate the current in a fault by dividing the rated voltage by earth loop impedance. It will be 153 amperes if the earth loop impedance is 1.5. And so if you, so you will understand this later. MCBs have instantaneous tripping curves. Instantaneous tripping is activated at around 10 times the IN. IN is the rated current. So if it is 10 ampere breaker, it will trip uh, instantaneously if the current through breaker is 100 amps. So we can use that to design uh, tripping characteristics of a TNC system. So we are going to learn these things, so don't worry. And so in this case, uh, our current is 153.3 amperes. So to select an overcurrent protection device for earth faults, we are going to divide this value by 10. 153.3 divided by 10 is 15.3, and we are going to select 16 ampere breaker, because 16 ampere breakers are available rated standard value. So that's how you are going to do. And don't worry about this C16. It is one of the notations we are used to indicate breakers. We are going to learn, this is one of the classes of breakers, C16. Okay. Now the second one, TNS system. TNS system is the most safe earthing system because and most expensive. In TNC system, so usually you have in Sri Lankan distribution systems and all, you have 4 wires in distribution lines. But in TNS systems, you have 5 wires because they are providing a separate wire which is connected to source earth in the distribution cable, distribution path or the distribution tower. That purpose of that wire is only for connecting to this load enclosures, exposed conductive parts. So this is one of the most expensive earthing systems, but very safe. Um, so that is everything you need to know about TNS system, because so we will do the earth loop impedance calculation for this. This is similar to the loop characteristics are similar to TT, but path is metallic. Okay, we will go to that. Okay, so earlier you may remember this is the loop impedance path to TNS. Earlier in TT we had this path through ground. There was a separate path to flow fault current. It was through ground or through soil. But in here we are replacing that with a metallic conductor. I think you are following me. This is similar to TT, but return is metallic, fully metallic. So advantage is earth loop impedance is low, fault currents are high. Overcurrent protection devices can be also used to identify faults. So the most important thing is in these type of systems, it is easier to find fault and clear them. And that is one of the major advantage, because RCDs can be less sensitive. So in Sri Lanka, our RCDs are 30 milliamperes. So very sensitive value. 30 milliampere is a very small current. So in here you the fault current is very high due to metallic path, and your RCD will have a, you can have a higher rated RCD to prevent earth faults. So that is the advantage of TNS system, and very expensive because you have 5 wires instead of 4. And read these things, you will understand these things, and listen to lectures again and you will understand. And if you have any confusions, you can put in the chat, or you can also send me an email or use WhatsApp. Okay. And I have summarized the things, safest system and overcurrent protection, and in here the RCDs are also can be implemented. I mentioned that, I think, because in here the fault current flows through PE, not through the neutral. So we can implement RCD. RCD between line 1 and neutral. So current, we can provide differential protection. Differential protection means we are measuring the difference between these currents in these two lines and tripping if there's a difference. Okay. High cost. High cost is also drawback of this TNS system, and protection coordination is easy because easy to find faults. And now we are having the TNCS. TN, that means we have combined separated. That means you are not having a separate PE conductor coming out of the source. We are having a smaller length PE conductor which is connected to neutral. So earlier case, see, this conductor is going to the source and again connecting to the neutral. But what we are doing in the TNC system is we are taking the PE conductor from somewhere around here, usually from the main distribution panel. So in usually TN CS systems are installed in in Sri Lanka. It is in dedicated transformer locations. That means high-rise buildings and all. So there are a lot of distribution panels. So from the main distribution panel, we are dividing this neutral into two wires like this. So assume in here we have main distribution panel. So we are connecting another wire to this neutral, and we are creating 5 lines from that points onwards. So in here, the advantage is we can have the same protection level as TNS. So this is the most optimum earthing system available because we can have all the features of TNS, safety, everything. Um, so if you consider about residual current protection, we can also have residual current protection because up to this point we can experience a difference. For I will I will draw it in the next. Okay, TNCS system. Uh, so current through here, and here will be equal because fault current is also combining with the line current from this point onwards. But if you can use the RCD in these 2 points, we can have the differential protection. So that is the advantage of TNC system. So I think you understood that. Did you understood TNC system? It's TMCS system. So this is actually similar to TNS, but we are acquiring the same protection level using a less cost. And here also in TN system, all TN systems, earth loop impedance is low. So fault currents are high, so less sensitivity devices can detect faults. Protection coordination is easy. Earth loop impedance, so you can easily determine the path and full metallic path. And those are the characteristics of a TNC system, TNCS system. So RCDs can be implemented. uh, I have summarized the things. Provide same safety level as TNS. Cost is lower than TNS, and these are the same things we had in TNS system. The sensitivity device like RCDs can be implemented, and also less sensitive devices can also detect faults, and protective coordination is easy. So I hope everybody understood. Did all of you understood these TN systems? Please tell me yes or no. Like if you need more clarification, I can elaborate more on those stuff. I think a lot of people are bored now. So can somebody say? Okay, no one is answering. Maybe few understood and few didn't. Right? Okay, no worries. We you will understand these things from the upcoming lectures. No worries. And now we are coming to the IT system. IT system is special because this is the only system that we do not have the source side earth, source side is isolated. So what happens in IT system is uh, there's no complete circuit to flow current. So if you have this circuit, so if you, even if you have a earth fault here, even if person the earth fault is not continuing to the source. So in here your what happens is, let's say you have a fault here, and your enclosure is energized to 100 volts. So what happens is, this earth is also in IT systems. I mentioned that IT systems are used in special locations. So in those special locations, there's something called uh, conductive conductive flows. So what happens is, you are standing on a conductive layer of flow. So if you if you if you have a if you have your enclosure energized to 100 volts, this flow will also energize to 100 volts. So there will be no current flow uh, through a human being touching this energized surface. So that is how we are keeping continuity in operation with these IT systems. So IT systems are usually very like specific kind of systems, so only used in operation theaters and special locations. And the main advantage is you can use this system without an issue even if there's a earth fall. That is the main advantage of IT system. And the only issue is, if you have a fault from another line, it is called double fault. So if you have now, if this enclosure is energized to 100 volts using a one line touching the enclosure. If one another line is touching the enclosure, there will be short circuits between uh, two phases, and you cannot keep the continuity of operation. So that is that is one of the things you should consider in IT systems. So the main thing is, IT systems can be used with an earth fault. So if you have two earth faults, you can't use it. Two earth faults from two phases, you can't use the IT systems. So in IT systems, there's no RCDs and all. What we do have is insulation monitoring device. So I said that you have conductive flows in here. So conductive flows are isolated from the ground. So we are having those things, and our enclosures are very the enclosures are not usually made out of metal. So those things are the characteristics of IT systems. And this is the summary of earthing systems. So these are the equations. So this is just the equation we had. The breaking condition means, so this is the breaking condition for RCD. So you can use RCD. So you may remember. So this is the equation. IN is smaller or equal to 50 over ZE. ZE is the loop current, loop impedance. So this is the breaking condition. So if it is IN exceeds the RCD value, um, your system will trip. And TNC system, you only have the overcurrent protection. In overcurrent protection, you are not considering the safe touch potential. You are considering the short circuit current, because so as I told you, the in TNC system we cannot use the residual current protection. What we are going to do is use overcurrent protection for earthing system. So this is the equation we can use for strip the circuit. So that is what mentioned there. And TNS system, we can have both of these breaking conditions. So we can have RCD and overcurrent. So that is what mentions here. TNCS, RCD, and overcurrent similar. These two offer similar protection, and uh, IT system does not have a breaking condition because we are valuing the continuity of operation. So it does not have a breaking condition, but we have insulation monitoring devices. So if there's insulation fault, we are going to see an insulation meter. If we can come to sleep in a day, we have one in our inventory. uh, okay, so those are the things you should know about earthing systems. So if you have any questions, you can post now. So there are several other slides also. Okay. um, so actually these two I don't think you have heard. Have you heard about ELR and EFR? Can somebody say, have you like heard about these two terms, ELR and EFR? Somebody can answer, please. Yes or no? Just a vote. We can take a vote. No. Okay. Okay. So actually in large installations, we are not going to use RCDs. What we have is ELR and EFR. So from the knowledge you gain from previous studies, so you know TT systems have a higher earth loop impedance, therefore we have a lower earth fault current. And TN systems, we have a lower earth loop impedance and we have a higher earth loop current. So our like residual current devices used for these two systems. For TT, we use ELR. ELR means earth leakage relays. So these are the residual current protection devices used in TT systems in large installations, ELR. So the term leakage stands for small currents. So earth leakage current, uh, earth leakage relays. So those are the things used for TT systems. And EFR. So you know TN system has higher currents. So EFRs are less sensitive. ELRs are very sensitive. EFRs are used for TN systems. So these two you should know when you're going to the industry. So I think today's lecture is a bit boring because you haven't been to the industry. If you have been to the industry, you have seen all of these things. ELR, EFR, widely available in all everywhere. We have these things in Slit also. We have EFR because we are having a TNCS system in the new building. I am not sure about the old building. And this is for your knowledge. And in the industry, you will have to configure. These are programmable, so you can configure the ratings and their stripping characteristics. So you can adjust those ELRs. So we are, and there are several other things you should know. And ELRs are so leakage current in TT systems. There's something called co-balance current transformers, CBCT. So you are going to learn these things in the protection lecture in the third year, second semester. Uh, CTs are current transformers. CT is current transformer. What it does is, if it measures the, it is like a clamp meter. So in this implementation, what it does is, usually in a balanced three-phase system, there should not be any uh, magnetic field around it because all the things are canceling out. So you are going to also learn these things in the PSA. So for this lecture, I'm just giving these things for your knowledge, not going to ask any questions from this. And CBCT is the uh, current transformer type we are going to use for ELR. And so if you can easily identify a system with ELR if it has a CBCT. CBCT is a very large ring. So all the huge wires coming through your transformer is going through this ring, and it is measuring misbalances in the system using electromagnetic principles. So usually CBCT ratio is 1 to 1. So I have given search why, so search about it. Maybe there might be a theory question from this smaller one. And the next one is EFR. EFRs are used in TN systems because TN systems has high fault currents. So usually those fault currents cannot be measured by a small device. What we do is we are using a current transformer to uh, uh, take a ratio for that, because if usually these are come in high ratio. So 100 amps through this line will induce 1 amps through this loop. So CTs work in that way. CTs are current transformers. So same principle as voltage transformers, it induces voltage in the other side, current in the other side, depending on the current which flows through it. I will show you some CTs. I will search in the internet. Now our lecture is almost over. I think this is the last slide. I will show you a few CTs. Don't worry, you will get how these things are installed. And so ELR will measure current through all those CTs and take actions to trip the circuit. So that's how ELR works. So additional knowledge, you will see these things in the industry. And you can now, the main advantage is earlier in the last batch they didn't have this knowledge when they are going to the industry. So they learn these things from industry. Now you are learning this from slit and going to the industry, so you can show them your knowledge. Okay, so and I think today's lecture is a bit boring, but you know, uh, theory parts are always boring, but uh, you will understand these things. Don't worry, nothing is not these things are not very complex. Okay, and I will show you a few CTs and CBCTs. Wait. I hope everyone can see this. Okay. Why? So one person is, are you going to ask me a question? Okay, you can ask questions. Okay, type your questions. I will explain the CBCT. So this is CBCT. I just found this image from the internet. So this is what it looks like. So you usually it works on the principle of electromagnetic induce. Yeah. So you know the when conductors are having electromagnetic field around it. So usually when you have three phases, these electromagnetic fields will cancel out and nothing will come to the CBCT. So they are using that principle to detect any misbalances in the phases. And usually current transformers, see these are current transformers. So usually current transformers, only one wire is going through them. So they are used to measure the current through that wire. So if you have seen non-invasive current sensors, these are the things we have in in those sensors. And in transmission lines, this is one of the current transformer we can see in the grid substation. So you are going to learn these things in electrical power transmission and distribution. That subject is also delivered by me, so you guys will learn about these things in that lecture. So for now you guys do not have to worry about these things, because these things you are going to first CTs and all, you will be introduced to these things in power system protection, because these are instrumental devices used to measure current and all. and you will get the understanding about them in that lecture. Okay, so if you have any questions, you can just ask me now, and you can uh, you can send me a email or WhatsApp message if you need anything. So do you have any questions? Okay, yeah, it's a mistake loop. So I think all of you have you guys selected the subject? I saw around 50 or 60 students have enrolled to the course in the course web. Are all of them are doing the subject, or what is going on? So actually this subject is very easy one. Even if you like, today we have theories, had theories, but usually examinations are very easy on this subject. So can somebody say, have you guys registered for the modules now? Okay. So now everything is finalized. So I have 60, I think 60 students in course web. Uh, I think maybe not everyone is doing the subject, right? Only 20, I think 22 is the count today. Maybe they are planning to listen to the lecture, right? Is that so? Okay, okay. So no answer. Okay, I'm going to finish the lecture now. Okay. Goodbye, everyone. Okay. Thank you for being here. Okay. Thank you. Okay. Thank you. Thank you. Okay. Okay. So I appreciate all the people who are answering. So otherwise, the lecture will be very much boring. I don't know how you people are going with the other lectures. I am using this technique, uh, even though today's lecture was a bit boring, right? Okay. Anyway, okay. Thank you. I'm going to now finish the lecture. Okay. Bye, everyone. Have a nice year.